So up next, I'll show you the patterns, and the pattern starts with strategy. So this is the strategy implementation of the ship. So we have two modes, player and attractor, and then we have the ship mode that's actually currently in use. And we start these up. We set these up at the beginning, and depending on who sets the thing, which is set state, you can. I don't think this is used. Initialize, yeah, this. I need to get rid of this set state. You initialize it through the ship, and then you set it equal to whatever. So that is done. What was I going on? So what I did, I did a little sneaky method of this. I have this move ship method, which is done by, let's move to AI. Ship AI, no, let's move to player. Ship player. So the ship player method, this move ship method, since this is done, the interface is done by ship player, ship mode, which has mushroom collision, since they both collide with mushrooms and it's kind of different to handle them. I just did it this way and then move ship. So the move ship method is done in the update method, and that sends in the input that the player specified, the position of the where the ship is, and then the speed that they're going. And if that succeeds, I'll show you that. So we take all the key inputs that are necessary, change the position, and then if the key is pressed and it does return successful, you return whether it returns successful. So that's used for sound. So when the user presses down and they can't shoot, they're not going to send the sound command. But when it does successfully shoot, you do send the sound command. And then mushroom collision just essentially negates what you're typing. And then that's the same thing with ship AI. So the AI, this is very incorrect. I could have done this with states but didn't want to because it would have been more work. It's essentially just having it bounce up and down with the randomization. So we have a counter that's constantly going off, and then a stop counter, or a Boolean. And then it essentially just bounces up and down throughout the game. I didn't do this with everything. I think this is the only thing I kind of hard-coded and didn't use a state pattern. I'll show you the rest of the patterns, like the actual implementation of the state pattern after this, which is the observer pattern. So the observer pattern is only used once. You make it sound like there was supposed to be a lot, but I didn't use it more than once. So the observer pattern is used by the flea manager. So the flea manager is an observer, and when you initialize the flea, you add the new observer to the mushroom manager, and that just does what it's supposed to. And then every time a mushroom is destroyed, remove mushroom. Every time the mushroom is destroyed, you update the observers with how many mushrooms are remaining, and then when that happens, which is done through observer update, which is what the mushroom manager does, so update observers, it will attempt to spawn the flea if the number of mushrooms that are still remaining is less than the amount of mushrooms implemented. And this mushrooms to spawn is done through the wave manager. It sets the information that is given to it through the text document. That's the only implementation I have observer that I know of. Next, I'll show you the simple states, factory. Oh, simple factory. Yeah, I have too many factories. Factories are everywhere. I think the most relevant is the centipede, Centi body factory. Nope. It just keeps track of all the information. There's all kinds of things that communicate to the pool. So every game object has a pool, a factory, and a manager. The manager handles as you want, more game logic. Factory handles. The factory and the pool definitely could have been mixed, and I kind of wish they did because it would have made my life a little bit easier. I'll probably do that in Engine, but I can understand the use for separating them, but for this I would argue you don't need it. But maybe I'll be proven wrong. They are implemented in the singleton. I learned to hate singleton by the end of this. I liked it at the beginning, and then I didn't. Properly destroyed and cleaned up. So pool. I guess I'll show you the mushroom pool. So the mushroom pool is done through every time it wants to mushroom manager. So in the initialize, we will request a mushroom. So you just keep going through, get a mushroom, set to external, and then what we'll do now is recycle mushroom is down here. So now when we destroy one, I remove it from the active list and put it into the inactive list. I have two lists because of removal. I don't know if there was a superior way to do this in teal. I didn't figure out if there was, so instead I just have two lists that keep track of what's on the screen and what isn't, and then when the cleanup comes, it removes them all. So it does do that, and then when we get to the end, it removes. So that's just one implementation of my many of factories and such. Singleton pattern I showed you already. They're not static classes, they're static functions. The command pattern I used more often than I expected. We'll go with one that you didn't make, which was, I guess we'll just go with sound. Did I do, were you sound? No, whatever. Sound manager is done through all of these, and you get the sound command that you want. It goes to the switch and returns what you want, and then processes all the information as you go. Demonstrate the commands are created only once. Show that the code is for storage and for processing commands. Okay. Finite state machine, I'll show you Centipede. Doing this was a pain for Centipede. Critters, we'll go with Centipede movement. And then we have Centipede movement collection, Centipede horizontal. So in my Centipede direction state, which is self-explanatory, we have a next state and an extra state, and then turning angle, which I never actually used, and get off that array. So check ahead, I'll show you, is done. Check ahead is done in the Centipede head. Check ahead is done through every update. So it checks ahead and then has the state handle what it wants to do. So any vertically moving state will count to 16, which is the sprite size, and then change the direction to its next state. And then any horizontally moving thing will only do this counter. I don't know why to name them X and Y counter, but it was too late at the time. And that just that's always moving and checking whether it needs to check ahead. So the vertical ones never check ahead. They just move down 16 and then switch over, while the X's are constantly checking. Well, not constantly checking, but checking enough ahead when it needs to. I have two states. I have next state, which is obvious, turns left, right, up, or down, depending on the state, and then I have extra state. So extra state is done in special things, special occasions. So if the centipede ever gets to the bottom, you call extra state, which determines what direction of up it will be going. So if it's going down and it was going to go to the left, it'll then say left up, as you can see. And then the X value one, or the horizontal. My headset keeps dying. The X value will turn it to poison, because if it's running into something on the X value, which is when it's actually checking ahead, it will be poisoned. So that is my state machine. I also implemented one in the flea. I didn't need to. It was more work to do it than I needed. I thought it would be cool to do it, but I definitely kind of regretted it because it took a lot of effort out of me. But I got it to work, and it worked. It works pretty well. So in the update, you simply just move the state thing and then state action. So the current state action is done. There's a take damage state for each fleet, and then there's a state action. So take damage for the first, we'll just set it to the second state, and then take damage for the second state, we'll just destroy it. And then state action for 1 is obviously spawning the mushrooms, and then state action for 2 I don't think does anything. So that's another state implementation. Didn't need to, but I did, and I kind of didn't need to. Observer pattern. Okay, you already. Explosions come in a few styles. Yeah, I think I showed you explosions. Explosion manager. These are the 3 explosions: spider, player, and critter. Critter is just the generic. That's the one you could barely see because I couldn't figure out the sizes for it. And then player death is a little bit bigger and correctly done. And that's display explosion. Each thing has an explosion type, and then it shows where it explodes. And then it's constantly, so because there can be multiple explosions at the same time, I just have a list. Boop-a-da-boo. This isn't necessary anymore. Where is it? Oh, a vector of explosions that it loops through with each draw. I know that's bad, but they don't last for long. So, and if there's explosions on the screen, I need to display them. It just circles through, draws them if they're not at the final frame, and then erases them when necessary when you're at the final frame. I don't have an object spool for the blaster, but it is only done a single time. Strategy pattern for the attractor mode. Why would I type that? Blaster is ship. The ship does have it, so it has 2 modes that are just done right immediately, so it doesn't have to change. And then I think I showed you this already, actually. Yeah, you set the state. Yeah, I showed you this. Bullet is also not factory generated. Oh yeah, the ship is a singleton. So the ship is done through a singleton because I started that way at the beginning of the thing, and then you taught us the correct way to do the ship. And it was like 5 weeks in, so I wasn't able to retract that. Bullet doesn't have a factory. It's not shown at all times, but it does have 2 behaviors where if it's fired or not fired. Oh, did you want to see it? Bullet doesn't have anything. Oops. Bullet barely has an update. Bullet simply just keeps track of, it just moves up and then marks the destroy if you're beyond the 0. There's nothing exciting behind that. Let's go. So next you want to see the centipede. So they are subclassed. The centipede part, I gave each centipede part has its own type. Centipede, or it has a following, and who you're following, who's following it. And that is handled through whatever. So I'll show you the centipede head. So centipede head is of type centipede part. And then what happens is when you create the bodies for the centipede, you set them wherever direction you're going, and you set the links in the creation of the body, so they always know who to follow. And then let's see, body manager. Yeah, so the body manager. No, maybe. The head and the body managers were very difficult because they handled the linking and the destruction and figuring out all that. So we have when a body is destroyed or a head is destroyed. Well, either way, when a head's destroyed, it sets the body to the head. So it'll take who's following it, set that body, and then give it the direction it was running in. And then when the head dies, or the head manager doesn't have much. So their subclass, compound base class. So the common code operations are simply what I showed you in the head, which is get who you're following and set it to the previous guy. Yeah, so and then when you create a head, which is head done through the head pool, initialize centipede, you get it from the centipede factory, and then initialize the head through all the information that you're given. You can assume that when you're initializing a centipede, it goes down at first. And then for solo heads, I get a random number, I set it equal to some random number left or right. and then that depends on what direction they're moving, and whether it be going right or going left. And then they just get a random Y variable to set it anywhere on the sides. Linking movement mechanism. So my approach was for linking. It wasn't a very complicated link thing. All I essentially did was set the bodies. I guess I'll just show you the code. What happens is we destroy the body. We take the body completely off the screen and then get a new head. And then we take all that information from the body and initialize the head with that information. So the body uses its location. It essentially just overrides the body, which I think is how you're supposed to do it. I set the bodies who it's following to nobody, and then tell the guy behind me who they're following in case anything changes, and then just fix everything at the end. And then obviously there's a test just to make sure nothing is broken. It's nothing too crazy. It works pretty well. I was surprised. I'm going to stop or clearly show the update. So the update, I think I showed you. Yeah, I did. I had to check ahead. So it's a very small update sequence. I simply just... So this is what I found either broke... Well, it broke my centipede either way. But before I was having this happen first, and then I decided to put this above, and it kind of fixed where the centipede head was located. That took more work than I would have liked, and it didn't even fix it completely in the long run, but it did do better. And then it sets position, and then we just have this random animation counter, so it's not spazzing out when it moves. Update the head. So the way that left then down. The way it's done to trigger is when you get to the middle of a grid. I'll show you the game grid actually next video. You check ahead using the offsets, and then what happens is check the grid ahead. It goes through this long thing of code. So if it's anything important like a glyph or a mushroom, it'll set it to the next state. If I've hit a poison mushroom, I use this extra state as I told you earlier. If it gets to the X or Y, it changes the state. It gets to the Y, changes the state, and then spawns the solo heads. When it finally goes up, it goes back up. If it is greater than Y, it gets the extra state, and then this was, I learned, this was necessary to send the information back to the centipedes of what direction it's going. So all it essentially does is just gives the guy behind you what direction to continue going in. And since this is only called every 16 frames or something of that sort, they're always moving. They're only getting a new offset every 16 frames, and then they're in their body. And then the centipede body just simply, where's the update? It just moves in the direction and does pretty much the same exact thing. That is done. Yeah. Centipede body, what was I talking about? Oh, and then yeah. So it just adds the stuff, checks ahead, and then it moves accordingly. Where's head? Yeah. And then demonstrate the movement collection only computer once per game. Yeah, so that is done through. This is the fun part of trying to figure out where I put everything. Yeah, that's done here. So this is the spider movement directions. So it moves in diagonals. I guess I'm going to tell you about the spider now. No, I'll tell you that next video. Centipede has these movement directions: left, right, up, or down. Offset for poison, which is just straight vertical. That's fairly, and then you get the offsets, which are done through. I think I showed you that in. No, I did that here. So movement offsets just done through here, straight then left. Yeah,